Hello, Kazi.
Yes, sir.
Thank you for joining.
স্যার একটা ছিল স্যার হিট ক্যাপাসিটি ডেফিনেশনটা হলো যেটা বললেন যেটা হলো হিট ক্যাপাসিটি ইজ দ্য অ্যামাউন্ট অফ হিট এনার্জি
Required.
required to raise the temperature of an object.
Required the temperature of an object by 1 degree Celsius because
By 1 degree.
we are dividing by theta, right? We are dividing by
Yes.
temperature, so it will be by 1 degree Celsius.
Okay, sir. 1 degree.
Clear? Like in your speed time graph, you got some ideas. You got in speed formula distance over time, right? Can you
Yes, sir.
remember?
Yes, sir.
Distance over time, we got total distance by total time taken. So here we are getting meter per second, right? Distance by every second. The same thing you will use everywhere, right? That's why I told you to link one idea with another one. Yeah, Rabi, Aisha, they are also joining. So, Saad, did you talk to them by this time? Rabi? Hello, Rabi. Rabi. Saad, Rabi. And all.
Yes, sir.
You tell them to join, eh? Tell them to join. Shimanto. Then Shimanto and who else left? Faiza, right? Faiza. Shimanto, Faiza. Then another student I mentioned. Whose name?
Farabi.
Farabi, yes, Farabi. So these three students, they were our regular students. Tell them also to join. They can sleep for this whole week, right? During the vacation time, 10 days vacation they are getting. Now they should join in the class, right? They should take part in the discussion. If they are taking part in the discussion, their ideas will help us. Our ideas will help them, right? There will be some exchange of knowledge, right? Isn't it? Hello? So this one is our topic, right? Thermal properties of matter. This one is our topic. We are done with the A and now B is going on, specific heat capacity. So let us go there.
Yes, sir.
Sure. Here is the contents and this one is the book. Your all three topics together I accumulated. Specific heat capacity is linked with heat capacity.
Sorry, can I tell something, sir?
About heat capacity?
Yes, sir.
Or specific heat capacity?
Specific heat capacity, sir.
Okay, tell.
Sir, specific heat capacity is the amount of heat required to raise the temperature of an object
Of 1 kg, 1 kg object.
Of temperature of 1 kg of object by 1 Kelvin
degree Celsius. Other things are same. Only one difference is here. There we use the whole
mass is mentioned.
Yeah, there we use the whole object, right? Like we are taking a big stone or big block of iron. That one we are considering the whole object, right? And we are thinking about the temperature range of the whole object. Now we will do the same thing for 1 kg object. Okay, that is your specific, that's making it specific heat capacity. It was heat capacity. When you are dividing by the mass, it is becoming specific heat capacity. So we are going for discussion on this, right? Kazi, hello Kazi. Kazi,
So in section 10.2, we see that heat capacity depends on the mass as well as the material of the object. It is therefore more convenient to examine the heat capacity per unit mass or specific heat capacity of the substance. The specific heat capacity is defined as the amount of heat required to raise the temperature of 1 kg unit mass of an object by 1 Kelvin or 1 degree Celsius. The symbol for heat capacity is C. Mathematically, the specific heat capacity C is given by C equal to C by M equal to 1 by M by Q by del theta.
okay, so I'm making it simpler for you. Look,
Okay.
here we have the main difference between heat capacity and specific heat capacity. It's becoming specific heat capacity because we are taking here 1 kg object, okay? And in the formula, here we are getting small c. For specific heat capacity, it is small c, and the heat capacity, it was capital C. So when you are dividing the heat capacity with the mass of the object you dealt with before, that one you have some mass, right? So that mass, if you write here, then it will become now specific heat capacity. This one we write here directly this way: small c equals q. This is q. Q equals m del theta. Okay. Q equal C equals Q by M del theta. So your capital C was Q by del theta, right? Isn't it? Hello?
Yes, sir.
Now the specific heat capacity, that is small c, that is becoming Q by M del theta. That's the main difference, okay? Your capacity, heat capacity and specific heat capacity, the difference. Here it is C, capital C equals Q by del theta, okay? Shafkat still did not join. Shafkat, Adnan Rahim. Yeah, Adnan Rahim is coming. Oh. So, Adnan Rahim, I'm admitting, yeah. This one. So, is it clear the difference? Difference between heat capacity and specific heat capacity, is it clear to everyone?
Yes, sir.
And we can relate also, if you know the heat capacity, you can directly use this formula to get a specific heat capacity, that is C equals capital C by M. This one, okay? Okay, is it clear?
Yes, sir.
You are putting this value here, then you are getting this formula, the third one. So done.
Yeah, sir.
Hello. So
Sir, I'm confused, sir.
yeah, Rabi, Rabi.
Yes,
Hello,
sir.
Rabi. Now, can you please tell us the briefing or the summary of heat capacity and
Yes, sir.
specific heat capacity relation? Then we will go for the queries. Okay.
Sir, the main difference I see is the mass.
Yeah.
Right, sir.
Yeah.
The difference is heat capacity is capital C and
Mm-hmm.
specific heat capacity is small c.
Mm-hmm. Very good.
And the difference in formula is Q divided by del theta, and here specific heat capacity will be Q divided by mass del theta.
Excellent. Excellent. So specific heat capacity is for only 1 kg object, right?
Yes, sir.
And heat capacity is for the whole object.
Yes.
Like you are taking a tank of water, a big tank of water. To raise the temperature of big tank of water, the heat required, it is heat capacity. Okay. Do you understand what I am saying?
Yes, sir.
And if you are asked to find the uh, heat required, find the heat required to raise the heat required to raise the temperature of the water by 1 degree Celsius, that is 1 kg water, only 1 kg water. That is giving you specific heat capacity.
1 liter.
Is it clear? 1 liter means we are dealing with the mass. That's why we are saying it kg. Okay. Uh, liter we will measure when we will dealing with the volume, not the mass. So don't mix up, huh? Is it clear now?
Yes, sir. Yes, sir.
Okay. So they who have still confusion, you can ask me now on the difference of heat capacity and specific heat capacity. Aisha,
Yes, sir.
Adnan Rahim, you understood?
Yes, sir.
Yes. So now you tell me what is the difference between specific heat capacity and heat capacity. Adnan Rahim.
Sir, their formula is different, but I forgot the formula, sir. But
The formula is in
the
front of you.
Ah,
Which one is for
okay,
specific heat capacity and which one is for heat capacity? You can understand from the screen, right? You can read it
yes,
from
sir.
there. Tell me from there the way Ravi told.
Uh, sir, um, sir, specific heat capacity equals to heat capacity divided by sir. What is M, sir?
Mass of the object.
Oh, sorry, mass. Yes, sir.
Very good. Specific heat capacity equals heat capacity by mass. That means
Yes,
heat capacity, if you divide by the mass of the object, then you will get heat capacity. Okay. So heat capacity you are getting, that is for only 1 kg object, right?
yes, sir.
And
Yes,
heat
sir.
capacity you are getting for the whole object.
Yes,
That's
sir.
the main difference. The other things are same. All other descriptions are same. Only there is one difference, that is the heat capacity is for the whole object and specific heat capacity is only for 1 kg object. Is
Yes,
it
sir.
clear?
Yes, sir.
So you be stuck with this idea, this concept. when you are differing or getting the difference between heat capacity and specific heat capacity. So Aisha, can you tell us what is the difference between heat capacity and specific heat capacity?
Specific heat capacity is divided by mass and also small c. It is like explained by small c rather than a big C. Correct?
Anything else?
And it is divided by mass.
Anything more?
Sir.
Okay, Saad, you want to tell anything?
Sir, I have a confusion, sir. The formula, sir, how it changed.
Yeah, tell me, where is your confusion?
Sir, first the C equal to Q by del theta. Then it goes to the small c equal to C by M. Then how
You
it
know it,
becomes
right? You know it this one before, right? Heat capacity equals the
Q by,
heat required divided by temperature change. This one you know before, right?
yes, sir.
And now you have this formula.
Yes, sir.
That is specific heat capacity. That is heat capacity divided by the mass of the object.
Yeah.
Till here you understood?
Yes, sir. Next part.
Then we are just replacing this one here. Okay, replacing this one here. If you want to see the steps, I will show you. Should I?
Yes, sir. Yes, sir.
Should I show you the steps? Like you can, after this, before going to this step, you can go here. In the middle, you can go here. C, small c equals, we are replacing capital C with this one. Okay, Q by del theta. By M, right? Can you write this?
Yes, sir.
Then we have here this one. Is lower part, we can write one small one, right?
Yes,
M by 1 to get the denominator. Okay, M by 1, can we write it? Anywhere we can
Yes, sir.
write this, right? M divided by 1 is still M. So the next part, I think now you understand. Look,
Yes, sir.
we can write Q by del theta. Mathematics is the language of physics, right?
Yes, sir.
So if you are good in maths, you can do better in physics also. Here, 1 by M. Can you write this way?
Yes, sir.
Now you got it?
Yes, sir. Now I got it, sir.
Q by M del theta. So done. Any more questions
Yes, sir.
here? Any
No,
more
sir.
questions? All are done? All the queries are gone?
Yes, sir.
Thank you so much. Now we are going for one numerical questions on specific heat capacity. Okay. Clear all drawings. Okay, before going to that one, we are just having this one. You know it, right, already? Just the unit. You
Oh,
see,
yeah.
here you have uh, C, small c equals, what? What is the formula? Can you say?
Yes, sir. Q by
Capacity
M del
divided
theta.
by.
M
Oh,
del theta,
sorry.
right? Temperature change.
Yes, sir.
That will be better to say del theta, temperature change. So here we got Q, joules, right?
Yes, sir.
Joules per
per
kg,
kg.
then degree Celsius, right?
Yes, sir. Kelvin, right, sir?
This way, first we write this way, no problem. Kelvin also we write, no problem. This way, same
Okay,
thing,
sir.
right? Joule per kg, you can write this way, kg inverse, right?
Yes, sir.
Then also you can write degree Celsius inverse. Okay, in place of degree Celsius, you can write Kelvin also, no problem. That's it, right? So from the formula it comes, the unit, if you know the formula, you can make the unit, right?
Yes, sir.
Okay, then they said another thing like we can convert, right, the equation, this equation, when the question is asking you to find the energy, Q, then you can rearrange the formula Q equals mc del theta, right? That one they wrote
Yes.
here.
And sir,
That's it.
the upper one, sir, C equals to MC. Big C
That's
equals to.
same thing, same thing. We got this one. C, small c equals capital C by m, right?
But sir, the upper one is for which one, sir?
If you are given heat capacity, if you are given the mass, okay.
Yes, sir.
If you are given a specific heat capacity and if you are given the mass, then you can find the heat capacity.
Oh, with that one, yeah.
From here it comes, okay?
Okay,
Is
sir.
it clear?
Yes, sir.
Now we are going for our numerical questions, okay? So you skip all these pages, huh? These pages we don't need now. When we will do with electricity part, then we need that pages, okay? Only do this one. Worked example 10.2. Worked example 10.2. So here we go. Yeah, Kazi. Kazi. Hello,
Sir.
Kazi. Please
Yes,
read.
sir.
Read the question.
An electric heating coil supplies 50 watt of power to a metal block of mass 0.60 kg and raises the temperature of the block from 20 degrees Celsius to 45 degrees Celsius in 90 seconds. Calculate the specific heat capacity of the metal. With what assumption did you make to arrive at your answer?
So when we get any numerical question, always I tell you to underline the given numerical information, right? Can you remember in class I told you several times?
Yes, sir.
Yeah. So that one I did here. I underlined the required information for this solution, right? Now the solution is there. What you got at the beginning? Can anyone tell me, Rabi? What is 50 watt? What is the unit for which quantity?
Uh,
You
Power,
know,
sir.
power. Excellent. So it is power. We just get it here, right? Here, power. Then what is this 90 seconds giving us time, right? Isn't it? Hello.
Yes, sir. Time.
So if your brain should work in a way that if I am given power and time, then we can find the work done or energy, right?
Yes, sir.
And this question is dealing with the energy, heat energy. So the heat energy we can find from this power and time. They are not giving us directly the way they gave before, the heat energy. However, they gave us some clues or the information from where we can get the heat energy, right? Is it clear?
Yes.
This way you can do the work. The other things you are very much familiar with, that 0.60 kg is given the mass, the temperature change 20 degrees Celsius to 45 degrees Celsius. This one you know, that is del theta, right? So what is our del theta?
25, I think.
Sir, 25, sir.
25 degrees Celsius. Very good. So we got here del theta, we got here mass, and we can find the energy. Now you can find the specific heat capacity, right, from this given information, isn't it? Hello. In your book,
Sir, then,
they did much more
sir,
steps.
0.56, sir.
0. Point what?
56,
What is
0.56 joules.
0.56 what?
No, sir. One minute, sir.
Your energy, you see, power equals work done by
Work
time,
done by 10.
or energy by time, right?
Yes, sir.
So we can write it this way, E by T, right?
Yes, sir.
Then our energy we can write this way, energy equals P times T, right?
Yes, sir. 4500, sir.
Yeah, energy equals P times T. All of you are getting it. Look, you have the problem with only rearranging, right? Again and again. So this one you should be very much familiar and expert. This formula we are using here, right? To get the heat supplied.
Yes, sir.
Then you are getting here the energy, 4500 joules. You got Q. You have now Q, right? This one in our formula we got Q, isn't it? So after getting Q, only you need, they are asking you uh, here uh, to find the specific heat capacity, right? They asked you to find the calculate the specific heat capacity, right?
Yes, sir.
So we have this formula, C equals what? Q by
Q by theta.
theta or Q by m del
No,
theta?
no. M del theta.
Here
M
it
del
is
theta.
specific heat capacity, right? C equals Q by m del theta. So the values you are getting, you should put here directly, right? Q you got, right? 4500. Then you have this one, right? After this you have these
300.
steps.
Sir, 300 joules per kg
Per degree
per
Celsius. If you
degree
are
Celsius.
writing per Kelvin, no problem.
Okay, sir.
So you got the idea how to do it?
Sir, in specific heat capacity, we have to write kg money in the answer.
Yeah, joules per kg degree Celsius or Kelvin.
Yes,
And
you
okay.
are correct. So in specific heat capacity, we are using joule per kg per degree Celsius, but in heat capacity, we had only joule per degree Celsius. Clear?
Sir, one confusion, sir.
Yeah, one confusion. Tell me.
Sir, joules per kg degree Celsius, right?
If you write this way, look.
Yeah.
If you are writing this way, joule, both are in the bottom, right? Both are in the denominator, joule per kg, and then degree Celsius. That is fine. Okay. But when you are writing in inverse form, then you have to write this way, joule per kg per degree Celsius. Okay, this way. Is it clear?
Yes, sir. Yes, sir.
Is it done, all of you? Any queries, anyone, please?
No, sir.
So can we go to the next one?
Yes, sir.
Okay, before going to next one, let's have a look on our learning outcomes. That will make us more confident about our learning outcomes, advancement. Here we have, look, look here.
Yes, sir. Yeah.
So this one, can you check how many learning outcomes are already done?
Sir, A describe a rise increase in its internal energy, random thermal energy. B define the terms heat capacity and specific heat capacity. Up to B we have done.
No, we are done also C.
Yeah. Recall and use the formula thermal energy mass into specific heat capacity into temperature change. Yeah.
So this one also we are done, right?
Yeah. From next class we will do describe melting and
Sir,
solidification
I
on
think
boiling and
Afkat
condensation
is following the old
in
routine.
terms of energy transfer with
Shafqat
change
is,
in temperature.
Safkat didn't came, sir. I think he has messed with the routine. I think he's following the old routine.
Old brooding timing, sir.
Yes, sir. I think.
oh,
I think he will.
can you give him
During
the message that the class is going on?
Great, sir.
sir,
Giving.
the class time is the class will over in 2 minutes.
When the class will be over?
11:50, sir. It's
11,
11:48 now.
11:50 our class is over, right?
Yes,
Yes,
sir.
sir.
Okay, now Kazi Jawad, you sum up the class, today's class.
What, sir?
You will sum up today's class.
I'm up to this class.
What we did, the class now
Oh,
going on, this 40 minutes only, not the previous one.
no, sir. We did the heat capacity. We learned we learned the difference between heat capacity and specific heat capacity.
Yeah, so what is the
Then the
difference?
formula of this.
What is the difference? Tell.
Sir, the difference between heat capacity and specific heat capacity there. In specific heat capacity, we like do the whole mass, like 1 kg mass.
Yeah, yeah,
So we raise the temperature of a 1 kg mass.
yeah,
No,
yeah.
sir.
Yes,
And
yes.
there is also a difference in formula also in heat capacity, specific heat capacity. Formula is 1 by m by heat absorbed, theta, then del theta, theta by del theta,
Okay.
Theta by delta, no, Q by delta.
q by del
Okay.
theta, which is
Here is
heat.
the formula available. Here is the formula. Okay, now Rabi,
Yes, sir. Yes,
uh,
sir.
Rabi and the other students who did not join the lab class. For them,
Yes,
I gave
sir.
some homework in lab. Okay, we had 2 lab classes, and for both of them, I gave some homework. Please go through Google Classroom, to get the homework and submit. Can you do
Sir,
it?
you got my one, right?
Yeah, I got your one, and also I gave you the reply.
Oh, yeah.
Okay, sir. I will
So
go
can
through.
you do it, all of you? Adnan Rahim,
Yes, sir.
Adnan,
Yes, sir.
your
Yes,
one I
sir.
still did not get. You told me that you would give me in the night, right? But you did
Yes,
not.
sir.
Then Aisha Ora, Kazi
Yes,
Zawad,
sir.
please submit the homework. Okay, I
So
think.
lab homework.
Okay,
I
sir.
didn't see it. I will
Yeah,
after
listen,
seeing I.
I am helping you. There is recording also. When the homework is given, there is also the recording available. So you can
Okay,
have the
sir.
whole class. Whatever you have to do, that one is also discussed over there in the recordings.
Okay,
So
sir.
it is very simple for you to do. Just you go through the recording, just enjoy the class, then you finish your work. That's it. It's not a tough task. Can you do it, all of you?
Yes, sir.
Okay. Okay. Kazi, Rabi, Aisha,
Yes,
Rahim,
sir.
submit your homework as soon as possible.
Okay,
Okay.
sir.
Sir, I will.
Anything else? Any queries?
No, sir.
Hello, sir.
Do you have any more class tomorrow?
Uh, no, sir, maybe.
Okay. If you don't have any more classes, then happy Eid ul Adha. Okay.
Yes, Eid Mubarak, sir.
No,
Eid
sir.
Mubarak.
Up to Wednesday, right? Our classes.
No, no.
No,
Till
no,
tomorrow.
Tuesday, tomorrow.
From
Oh,
Wednesday, you are closed.
oh,
Okay.
Arey, ja. Oh,
Okay.
যাক একটা
Allah
বাইচে
Hafiz.
গেছি
Thank you all for joining.
Saad is upset.
Thank you
Okay,
all
sir.
for joining.
বাইচে গেছি বেটা নুরুল স্যারের আরেকটা ক্লাস ছিল
Okay.
করবো না তো। আচ্ছা, ঠিক
God
আছে।
Okay,
bless
sir.
you. Allah Hafiz.
ওকে স্যার
Yes,
আল্লাহ
sir.
হাফেজ স্যার
Assalamu alaikum, sir.
আসসালামু আলাইকুম ওয়া রাহমাতুল্লাহি ওয়া
Wa alaikum
বারাকাতুহু
salam.
আমাদের
Mubarak.